Okay, so this one is going to go over IXL B11 or 59F, if that's how you want to search it. So this is dealing with the distance formula, and so we're going to have to practice the formula. Now, the thing it's not going to tell you is what the formula is. So it gives you 2 points and it asks you to find the distance, but you need to know the formula first. So it looks like this is x to the second minus x to the first squared plus y to the second minus y to the first squared, all under a radical. All right, so the first thing you have to figure out are these subscripts. So it says like x to the second minus x to the first. What in the world does that even mean? Well, it's because when I give you 2 points, when there's an x and a y, I have to indicate which x I'm talking about. So for example, this is the first one and this is the second one. So this would be the first y and this would be the second y. All right, so my thing that I do is I fill out the entire thing and then just plug in those numbers first. So how I fill this out is just like this. Everything up, and then we're going to plug in these numbers. So x2 is 3, x1 is 7, y2 is 7, and y1 is 4. So once we plug those in, we're just going to do this one step at a time. So let's do inside the parentheses. 3 minus 7 is negative 4. 7 minus 4 is 3. I didn't do anything else, just inside the parentheses. Now let's do the squaring part. So negative 4 squared is 16 plus 3 squared is 9. Do this again. And then we have 16 plus 9, which is 25. Now, it says write your answer as a whole number or a fully simplified radical. So the square root of 25, this is a perfect square. We can simplify this even farther because the square root of 25 is 5. So that's what it means by whole number. Most of the time it's going to be stuck under the radical. In this case, though, it just didn't work that way. It was a perfect square. So let's try another one. So again, doesn't give you the formula. X2, and eventually you'll start doing these and you'll start memorizing the formula, which is the plan. All right, so let's go ahead and plug those in. Sorry, my radical lines aren't the straightest. All right, so we have, I always label them because I forget. So we have x squared, which is 7 minus 10 plus negative 8 minus negative 9. Okay, I want to just draw a little thing to this. So this is a minus negative because the formula has a minus sign in it, like a subtraction symbol, so that came down. And my y1 just also happens to be a negative. So it is minus negative. I promise you they will do this to you on purpose. They want to make sure that you know what a minus negative turns into. And every time you see a minus negative, just make it a plus positive. They counteract each other. All right, so let's do what's inside our parentheses. 7 minus 10 is negative 3 plus negative 8 plus positive 9 gives us a 1. Remember, it was a minus negative. We did a plus positive. Negative 3 squared is 9. 1 squared is 1. Square root of 10. Now we look at the square root of 10. It can't get simpler than that. So it is just the square root of 10. Okay, let's do another one. So these are from your USA test preps. So we did the distance formula before in IXL, but now we're going to actually apply the distance formula and the reason we even did it in the first place. So because it wants the perimeter. So we actually have to find all 3 distances in order to add them up to find the perimeter, okay? So let's just find A to C. Well, the first thing I'm going to do is I'm going to go ahead and write these coordinate points down. 1, 1. This is 4, 5. This is 9, 2. Okay. So we have at least our point. So let's just find the distance between 1, 1 and 4, 5. Okay, I'm labeling my points, x1, y1, x2, y2. We're going to get my formula. Okay, x2, which is 4 minus 1, and then 5 minus 1. 4 minus 1 is 3 squared, plus 5 minus 1 is 4 squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. We've done this distance before. The square root of 25 is 5. So between these two lines, my distance is 5. So now I'm going to use the formula again to find the other two sides. Okay, so I'm going to do, I'm probably going to erase this just so I can make some more room. Okay, so now I'm going to find the distance between 4, 5 and 9, 2. All right, I gotta find the distance between those two. All right, so I'm gonna set my formula up as I always do. So we have x2, which is 9. Oh, let me label them. 1, 1, x2, y2. x2, 9 minus 4, and 2 minus 5 squared. 9 minus 4 is 5. 2 minus 5 is -3. 5 squared is 25, plus -3 squared is 9. And this turns into the square root of 34. Now 34 can't be simplified anymore. This is truly just going to be the square root of 34. And then I'm going to erase all this, and we're going to find one last distance between A and B. Let's do purple again. So A is 1, 1, and the other one is 9, 2. It doesn't really matter which one goes first. You're just trying to find the distance. So x2 and y2. All right, let's get that formula going. So we have 9 minus 1 and 2 minus 1. So we have 8 squared plus 2 minus 1 is 1 squared. 8 squared is 64 plus 1 squared is 1. Then we have the square root of 65. So this distance is square root of 65. This is not going to be simplified either. I know you want to, but just leave it underneath the radical. Okay, so now that we have all three distances, it still wants more. It wants us to find the perimeter. Well, in order to find a perimeter of a shape, you need to add all of the sides up. So we have 5 is one side, square root of 34 is the other side, square root of 65 is the other side. None of these guys are like terms, so this is your perimeter. That is as good as it's going to get. All right. I think I have time in this video to do one more. Okay, so let's find this. Let's label these points first. 1, 2. This is 2, 4. And this is 5, 2. Okay, so I'm going to find this distance first. So let me label my points. 1, 2, and 2, 4. We have x1, y1, x2, y2. Formula. Okay, so we have x2 minus x1 and y2 minus y1. 2 minus 1 is 1. 4 minus 2 is 2. 1 squared is 1. 2 squared is 4. And this is the square root of 5. That's not going to get any more simplified. So this side is the square root of 5. All right. So I am going to erase all this so I can do it again. Let's pick a different color. All right, so now let's find this distance. We have 2, 4 and 5, 2. Okay, so formula. Okay, so we have x2 minus x1, y2 minus y1. 5 minus 2 is 3. 2 minus 4 is negative 2. 3 squared is 9. Negative 2 squared is 4. So this is going to be the square root of 13. Not going to get any more simplified than that. And we'll do one last one to find the other side because it still wants the perimeter. So now we got to find this very last side. So that's the distance between 1, 2 and 5, 2. Now, the cool thing, I'll show you a little secret when you have a straight line. Sometimes you don't have to do the distance formula. You can just straight up add 1, 2, 3, and 4. You are going to get 4 here. I'm just letting you know. If it's a straight line, you can totally count the distance. So we don't have to use the formula. Will save us a little bit of time. But anyway, so finding the perimeter, we have 4 plus square root 13 plus square root 5. This cannot get any more simple than that. We can't combine them. They're not like terms.